Hello, grade 9. So this is section 2 of chapter 21. In this lesson, you are going to compare the speed of sound in different media, to explain how frequency and pitch are related, to describe the Doppler effect and give examples of it, to explain how amplitude and loudness are related, to describe how amplitude and frequency can be seen on a oscilloscope. Now, first, the speed of the sound differs from substance to another substance. Okay, we can say that the sound is very fast in air, but it's also faster in liquids and even faster in solids. The reason is the particles in solids are very close together, and in liquids it's close kind of more than the air, the particles. So the travel of the sound waves can be more faster in solids. Now, also, the temperature affects the speed of the sound. The higher the temperature, the faster the sound speed is. Here we have this table shows the different temperatures of the air. At zero, the speed of the sound it's 331. Here the air 20 degrees Celsius, the speed is 343, and if it's 100 degrees Celsius, the speed is 366, and in the water it's more, and in the solids it's even more and more. Now, this is how to express the loudness of the sound. Pitch and frequency. What is the pitch? It is a measure of high or low a sound is received to be depending on the frequency of the sound wave. Okay, so how low or high sound seems to be, we call it a pitch. Okay, the frequency of the wave is the number of crests or throats that are made in given time, as we said before. So the pitch of a sound is related on the frequency of the sound wave. Okay, we say that the higher the frequency, the higher the pitch, and so the loudness will be more and more. We express the frequency as we said before in hertz. Okay, we said before also the frequency is the number of waves per time. Okay, and we said that the hertz is a wave per second. Okay, now frequency and hearing. Not every sound we can hear. We can hear in a range of sounds. Okay, above this range and below this range we can't hear it. That's why sometimes the dogs hear, or the animals in general hear something we can't hear. Okay, so the sound that have a frequency too high for people to hear, we call it ultrasonic. We call it ultrasonic. So if you asked about what is the ultrasonic sound, it is the high frequency or higher than the frequency that the people can hear. This is about the Doppler effect, which is show how the sound you hear if you were behind the car, if you were in front of the car, why the sounds are different, and why the driver can't feel the change of the sound while he is traveling with the car. Now let's see the discussion here. This higher pitch was result of the Doppler effect. Okay, what is a Doppler effect? It's the apparent change in the frequency of a sound caused by the motion of either the listener or the source of the sound. So it is the change of the source when it is high, when it is far away or close to you. In a moving sound source, such as a car with the horn knocking, sound waves that are moving forward are going the same direction the car is moving forward, the same direction. Okay, as a result, the compression and refraction of the sound wave will be closer together. Look at this. Here the compression is closer together because the car is moving forward and pushing the air like this. Okay, now closer together than they would be if the sound source was not moving. A person in front of the car, the frequency and pitch of the sound seem high. Okay? After the car passes, it is moving in the opposite direction that the sound waves are moving. Okay? To a person behind the car. The frequency and the pitch of the sound seems low. The driver always hears the same pitch because the driver is moving with the car. So again, when the car is going like this, so the compression and refraction here is going to be higher. So you are going to hear it more. And as the car is moving away from you, you are going to hear it lower, because it's going in the opposite of the source of the sound. So you are going to hear it low and low and low. The driver, the sound doesn't change because he is traveling with the source of the sound. Okay? We call this Doppler effect. Now, about this title, loudness and amplitude. What is loudness? The loudness is the extent to which a sound can be heard. Okay? So what is the extent point that we can hear this sound? If you gently tap a drum, okay, you are going to hear a soft trumping. Okay? But if you tap it harder, then you are going to hear it much louder. Why? Because by changing the force you use to strike the drum, you are changing the loudness of the sound that is created. Okay? So, energy and vibration. These are the explanation why when we strike it harder, we are going to hear it louder. Why? Because energy is going to be more. As you strike the drum harder, you transfer more energy to the drum, and then the drum moves with a larger vibration and transfer more energy to the air around. Then the air is going to be vibration more, or vibrate more in energy, causes air particles to vibrate further from their rest position, and this will be, it's going to be more vibration, then more sound or louder sound. Increasing amplitude. So a drum, when you strike the drum harder, you are increasing the amplitude of the sound wave being made. So the amplitude of a wave, as we said before, is the largest distance the particles in a wave vibrate from their rest point. Okay? So we said also before that the larger amplitude, the louder the sound. Okay? The larger the amplitude, the louder the sound. And the smaller the amplitude, the softer the sound. One way to increase the loudness of the sound is to use an amplifier. Amplifier like this one, the boy here is using. What happens in the amplifier? An amplifier receives sound signals in the form of electric current. The amplifier then increases the energy and makes the sound louder. Okay? So the amplifier increases the energy and then make the air vibrate more, and then the sound will be more. Now, how to measure the loudness? We have something called decibel. Okay, decibel. The softness sound an average a human can hear at level of 0 decibel. Sounds that are at 120 decibel or higher can be painful. Here we have many decibels for different sounds. Look at them just to know them. Don't memorize them. Now, how to see the amplitude, okay, and frequency? We know that the sound waves are invisible. We can't see them. But however, technology can provide a way to see sound wave by a device called what? Oscilloscope. Okay? So this device can graph representations of sound wave as shown in this figure. Look at this. Here we have the graph on the right has a larger amplitude than the graph on the left. So the sound represents on the right louder than represents on the left, as you can see here, because we have higher amplitude. So this is higher than this. Here you can see that the graph on the right has lower frequency than one of the left frequency. It's lower. Okay, so the sound represents on the right has lower pitch than one represented on the left. You should know these diagrams. So I might bring like this picture and ask you which one is larger, or this shows larger, this is larger than this, or the amplitude about the pitch, about the amplitude, about the frequency, and etc. Okay. The last section is about from sound to electrical signals. We said that this oscilloscope can change the sound into electrical signals as shown here. An oscilloscope is shown figure 7. A microphone is attached to the oscilloscope and changes the sound wave into electrical signals. The electrical signal is graphed on the screen in the form of a wave. Okay. Then the graph shows the sound as if it were transverse wave, so the sound's amplitude and frequency are easier to see. The highest points اللي هي الكريست بسميها of these waves represent compression, and the lower points, we call them throats, represent refractions. By looking at the display on the oscilloscope, you can quickly see the differences in amplitude and the frequency of different sound waves. So you can see, like here, you can see the frequency, the amplitude, the crests, the throat, and etc. of these things. This is the oscilloscope. You have to solve these questions. Now in the group, in WhatsApp, we are going to ask students by turn to answer these questions and to see if you understand or not.